All right. So I unfortunately forgot to turn on my microphone, so this is going to be me recording over the video, so it might be a little bit weird. But just roll with me, and hopefully we'll try and stay as synced up as possible. So we're going to talk about polynomials. So polynomials are, we've already talked about them a bit. So quadratics are a form of polynomials, as are linear functions and that sort of thing. And so a polynomial is just a collection or a string of monomials, right? And so a monomial is just a singular term, okay? A monomial is like, if you think about something like 6x maybe, or something like that, where it is just we'll talk about it as a coefficient, which we're going to represent by a subscript n, okay? And that subscript n is going to be referring to just the term number, and we'll talk a little bit more about that later on. And then specifically for polynomials, we'll look at an times x raised to the nth power. Okay, so if I'm talking about a quadratic, maybe I would have 3x squared. The 3 would be my coefficient, my an, and then x squared would be an n of 2, right? So that's a monomial. It's just a singular term. Okay, and so what a polynomial is a string of those in descending order of powers. So I start at x to the n, and then I go to x to the n minus 1, and so on and so forth, all the way down to x to the first, and then x to the 0th, which we don't necessarily have to write, because anything to the 0th power is just going to be 1, so that's just our constant term on the end. Okay, so again, we want to write it from the highest power down to the lowest power. And so the highest power is going to be n. And so what we call the highest power is we call that the degree. And I have likely written that down in here at some point. And so we'll see which number, when I wrote that down. Another thing to mention is that my highest number of terms, or the maximum number of terms I'll have in a polynomial, is whatever my degree is, or whatever my highest power is, plus 1 terms, right? So if you think about a quadratic here, I'm writing one out. I've got x squared as my highest power. It's a second degree, okay? And so I've got 3 total terms. I've got the x squared, I've got the x, and then I've got the constant, right? So 3 terms, second degree polynomial, so I have n plus 1 terms. That's not to say that I couldn't have more terms, but that is to say that if I have more terms, I can simplify and combine like terms and get down to a maximum of n plus 1 terms. I could potentially have less if I didn't have a constant, or if I didn't have an x term or something of that nature. But the maximum number of terms I'll have is that highest power plus 1. Right, so any quadratic, any x squared, will have a maximum of 3 terms potentially. Right? Okay, what are we going to talk about next? Okay. So all of that put together, that f of x plus some number of, your string of terms written in descending order, that's what we call a polynomial function. So each of those terms individually is a monomial. We string them all together, gives us a polynomial. So maybe some of you guys have taken some Latin, or just you've heard poly before, poly referring to many, and then nomial is just a number, a term, that sort of thing. So the string of all of those together make up what we call polynomial functions, right? So what are we going to talk about next? So part of the issue is I'm writing while I'm recording this, so it goes a little bit slower than me recording over top of it now. That's why hopefully next time I'll remember to actually turn on my microphone. All right, let's see here. Yes. So the highest power gives us the degree of a function. Okay, and so you'll hear degree, and the reason that this is so important is like with when we talk about with quadratics, right? That x squared gives us a lot of properties that a linear function doesn't have, because that x squared is the highest, it's the most powerful term in there, and so it really affects what our graph ends up looking like and the behavior of it, right? And so maybe you can guess that if I had x cubed or x to the fourth or something like that, I would also change some of the properties of what my graph might look like and how it might behave, right? And so we talk about the highest power as the degree. I don't care what the coefficient is. So you'll see here, I've got 3x squared plus 7x. The highest degree term is the 3x squared because that's the highest power, okay? We don't care about the size of the coefficient. I know that 7x looks like maybe the larger term because of that 7, but that 7 is not as strong as an x squared, if you will, right? That's just a coefficient. We care about the degree, which is also the highest power. So any quadratic, any x squared as the highest degree, that's going to be a second degree function, right? Looking at this next one here, I've got 4x plus x squared minus 3x cubed plus 1. So I find that highest power. That's negative x cubed. And so that tells me the degree of my function, right? That 4x looks like maybe the biggest term. It's also in the front. But what we care about is the power, which we have at 3. That is our highest degree, right? So they may not necessarily be in a proper order. It doesn't really matter. We really are just looking for that highest degree power. So I'm looking at each term and I'm saying, is this the highest degree power? Is this the highest degree power? Is this the highest degree power? And we're trying to check that out. All right, what am I getting at here? We will see. All right. So next thing we want to talk about is the leading coefficient. All right, and the leading coefficient is the coefficient that's attached to our highest degree term. So I find the highest power or the highest degree term, and I find the leading coefficient. So for example, in this negative x cubed, that -1 is going to be our lead coefficient, and that determines things like, remember when we had our a term out front of a quadratic, that would determine whether it was opening up or down. The same sort of thing's going to happen here, although it maybe sort of has a little bit of a deeper meaning, and we'll talk about something called end behavior that's going to be largely influenced by the degree as well as the leading coefficient, right? So again, in that quadratic there, 3x squared plus 2x minus 1, that 3 is going to be the lead coefficient of the highest degree term, and so that's what we call it, the leading coefficient. A coefficient, if you don't remember or don't recall, is just a number that we're multiplying something by, right? So I'm multiplying my x by a coefficient. It sort of scales up the values or something of that nature, or scales it down depending on what it is. The next thing we're going to talk about is the constant term, right? So I've got at the end, I've got a naught, so it's a 0, a 0 subscript 0 times x raised to the 0th power, and so x to the 0th power is just going to be 1. I just wrote it so that you can see how the formula sort of works out there, but we can sort of ignore that x to the 0, and we've got a naught, which is just a constant, which is just a number that we're adding on to the end. And so this is going to tell us in every case what our y-intercept is, right? Because if I plug in 0 for every x, all of those other terms cancel out, and I'm left with the constant term, which tells me exactly what my y-intercept is. And so that's what the constant term is, okay? So that leads me to, we want to be able to write our polynomials in what we call standard form, right? We talked about a standard form quadratic as a quadratic that it's written as ax squared plus bx plus c, right? Ax squared, highest degree term, plus bx is the second highest degree term, plus 1, which is that constant term. So they're written in descending order of powers. Okay, and so let's take this example here, 4x plus x squared minus x cubed plus 1, and write that into standard form. I want to bring the negative 3x cubed to the front, and then the x squared, then the 4x plus 1. You can see how that's written in descending order, and that's what we call standard form. The benefit of writing things in standard form allows us to easily identify the constant term as well as the highest degree term and the leading coefficient. What I was showing you there is just that we may be missing terms, right? Like the 4x may not be there. We still want to write it in descending order even if we're missing terms. So if the 4x wasn't there, then it would just be negative 3x cubed plus 2x plus 1. Okay? And so when we write things in standard form, it makes it a lot easier to determine, or rather to pick out and use the information like degree and leading coefficient to talk about graphical features like minimums, like maximums, like the end behavior of the graph, those sorts of things that we sort of care about. The last thing we're going to talk about is types of polynomials. So I got a little lazy and abbreviated, but there are, we're only going to talk up through degree 4 polynomials, and that's because the things that we know about polynomials apply to 5th degree and 6th degree and 7th degree. So we're going to learn it easy, and then you'll be able to apply it on a higher level. Okay, so the first one is a constant. That's a degree 0 function, and it's something like f of x equals 1. So that's just a horizontal line through, through 1 or through y equals 1, y equals 2, something like that. Our next degree is a first degree, which is a linear, and so that's something that's in like slope-intercept form, right? F of x equals 2x minus 1, okay? Quadratics, we're very familiar with these, hopefully. Quadratics has a degree 2, and then that's something like f of x equals 3x squared plus 2x plus 1, right? And so each of these are going to be written in standard form. The new ones are going to be third degree, which we call a cubic, okay? And so a cubic is something like x cubed plus 2x squared plus x minus 1. As long as it's got the highest degree term being x cubed, then it's a cubic. And then finally, fourth degree, which we call quartic. That's something like 4x to the fourth. And maybe we're missing some terms, so maybe it just goes to x squared minus x minus plus 7, right? We don't necessarily have to have the x cubed. It's defined by that highest degree term being 4x to the fourth. Okay, so on and so forth. We could have 5th degree, 6th degree, 7th degree, and all of that is determined by what the highest degree term is. If the highest degree term is an x to the 8th, then we have an 8th degree term. It doesn't matter what other terms come in, so long as they're all less than that x to the 8th, right? And so again, all of these sort of things that we talk about with these smaller degree polynomials apply to higher degree polynomials. And these sorts of things are used, it's the most widely used branch of mathematics, I would say, across many disciplines, are polynomials and exponential functions, right? Polynomials are used in code breaking. They're also super easy to manipulate and that sort of thing. It looks like I'm running out of time, so we'll end the video here.